Welcome everyone to the Ideas Seminar Series. I'm delighted to introduce Sumeet Kumar, who is our speaker today. Sumeet is a just vented PhD graduate student. He just got his PhD and he will be now Dr. Kumar. So welcome him to that. And this is his first talk after getting his thesis basically finalized. So he's going to be talking us today about some work in stance mining and what that means and how it is used and how it helps us better understand social media information. And he'll give examples for utilizing it to look at various groups, again, with examples from coronavirus and so on. With that, Sumeet, take it away.
Thank you, Professor. Hi, everybody. I'm Sumeet Kumar. I'm going to talk about social media analytics for stance mining. And in particular for a stance, we mean like whether a person is pro or anti a given topic. And the examples that I'm going to use for understanding these techniques are from coronavirus discussions on Twitter. Note that these are still preliminary results. So feel free to pinch your ideas or if you have any questions or anything, feel free to email me or ask me after this talk. So before we go into this, the methods of stance mining, this entire talk is basically driven by some of the controversial topics that we saw recently. And in particular, I have chosen 3 topics for which I want to understand the users, their stance, and how it varies. So the first topic is firing Dr. Fauci. As you know, there was a recent conversation. I think it was there, but it's sparked by a retweet by the president. So that's going to be our first topic that we are going to use for analysis. The second topic is pretty common these days on Twitter. The question is whether America should open for economy to run or not. And this is a broad question of open America, but we also have like open states, like open Pennsylvania and other states. So there is kind of a movement that's being seen on Twitter where users want some parts of the country to open up. And the third is about immigration ban. This is again something that was recently started when Donald Trump tweeted on immigration ban that recently happened. So these are the 3 topics. But to understand these topics and the stance that users have about these topics, we need to talk about some basics of stance mining and how we can use stance mining for this purpose. So my overall goal for this topic is to answer 3 questions. And the first question is, how do I identify the users who are pro or anti a given topic? And I propose a new method for this, and I'll talk about why a new method is necessary. In particular, just to give you a glimpse, the method that I'm proposing does not really require a lot of hand labeling. So it's kind of either very much towards unsupervised learning, which kind of makes it very flexible to analyze any topic that you want to analyze. So that's the methodological part. The next part of the talk is going to about how the 2 groups, pro versus anti, differ in their discussions. And so whether a group is smaller, a group is bigger, what kind of news sources or pictures they are sharing. How do we answer that question? And the third is how the users differ in their stances on these topics. For example, are users in Fire Dr. Fauci camp, they're all Trump supporters, or there are also some users who are non-Trump supporters or anti-Trump, and they are still trying to have a stance which is about Fire Dr. Fauci. So these are 3 main questions that I plan to suggest answers in this talk. Before we go into details, let's have some definitions clear. So what a stance is? Stance is defined as a mental or emotional position adopted with respect to a proposition, a person, an idea, etc. We know about person, we have a lot of controversial figures about whom people have pro or anti stance. It could also be often as a proposition. You can say that this bill is good, and that is a proposition, and users or people can have stance on it. It's often categorized as pro, con, or neutral. Also, the other terms often used as favor, anti, or unknown. So before we go into details, so the question is, what is the current methodology of understanding user stance? So there has been work on two different approaches for stance mining. The first one is more on the shown on the left side, which is language-based approach. This is where a text is given and maybe a topic is provided, and then the question that's expected to infer is whether the text is pro or anti given the topic. There is also a related paradigm, which is more of a network-based approach, where we have a set of users who are interconnected in some way using a network, and then often we see that a few users, we know their stance, and then that we can use that to basically propagate it to the entire network and know the stance of all the users. So these are the major themes of research that has been happening on stance learning or stance mining. Now, the first one, which is on the language-based side, I think it's there for a few years, like 5, 10, 12 years. But I think it got popular with the SumMevel competition 2016, which is about detecting stance in tweets. And the standard format is like there is a text, which is commonly from a tweet, and then there is a topic, and the question and the prediction has to be done whether it's a pro or anti that given topic. So that's the text-based approach. But in addition to text-based approach, as you might guess, there is a lot of information in the networks that users have, and that could also help you to learn stance of users. For example, I'm showing an example here. On the left side, we have a well-known TV personality who has a number of followers and followings. So I'm trying to highlight that because followers and followings would also help to understand stance that the person might have. But in addition, we also show, like on the left side, there is a tweet that he sent, and then there is a retweet by a lot of users. And one of them, user, has very clear stance terms mentioned in her profile information itself. So that's on the left side. On the right side, again, I'm showing some more information. So here I have a user who has tweeted something, and then there are retweets and likes, and then there are comments to it. So all these are different ways where you can infer stance of users, where different type of connections that you can have. And that is what has been tried in some of the recent research work. So for example, this one is from 2018, from 2011, where the researchers tried to understand political polarization on Twitter, in particular trying to understand who are the left-leaning users and who are the right-leaning users. So this is more of a network-based approach that I just talked. All right, but there is a problem with often these network-based approaches. So what I show on the left is the network that's commonly used. Now, if you are someone who has worked a lot in network domain, you understand that this is not a very real network because who are more like isolates. They won't be engaged in kind of discussions. For example, this one on the left, it's a retweets network. A lot of users, they don't retweet. They might just tweet, they might just like, and they engage in other types of conversations. But they are never present in this kind of discussion. And that's what being shown on the right side, that often what happens in network-based approaches is that we ignore a pretty large fraction of the users because what we do is we take the largest component of that large network and we just do analysis on that large network, assuming that the information that we learn from that largest component is basically a signal that can be translated to the entire network, but that's often not true. On the right side, I basically show a more of a realistic network, where you have a lot of isolates and a lot of very small components as well, which are basically disconnected from the main component. So just to summarize, what are the three main challenges that I see with the most recent approaches with stance mining? First one is the language-based approaches. They are mostly supervised machine learning based. And as you know, supervised machine learning requires labeled examples, and labeling examples is often very expensive. The other one is the network-based approaches, which are kind of, we don't require a lot of labeled examples. They are more on semi-supervised approaches, but they can't handle isolates. So these are the, and the third one, which is, I guess, is much more important, is that with stance learning, what happens is that topics change fast and new topics emerge. Now you can see in last few weeks or last few days, like you have seen new topics that are coming up, for which you might want to know what's the stance of the users have and how the users are distributed, whether pro or anti. Because topics change fast and new topics emerge, this makes the first two problems even more important. So you can't go back and every time relabel a few hundred examples just to make sure your supervised machine learning works, or on the next side, whether you have sufficient network, but you really can't use all of them because the network-based approach is commonly just to look into the largest component of that network. So that's something we want to handle in this research. So as you might expect, the goal here is to take the benefits of both these approaches, network-based learning approaches and text-based learning approaches, and then try to break the stance of users in a more realistic network. And on the right side, I saw a realistic network where we have a lot of users who are connected via retweets pattern, but there are also a lot of isolated nodes which are not connected at all from the largest with the largest component. All right, so I think one slide that kind of summarizes what's coming next in this methodology part, the first half of this talk, is basically what's being shown in the slide. So I have 3 steps for it. I start from, let's call it black box network. It's just users who are connected via some interaction. And the only input that I want to give is being shown in the step 2 is a few labeled examples, labeled hashtags, sorry. So a labeled hashtag could be like hashtag gun control now, which is pro gun control, and hashtag second amendment, which is more of an anti gun control. And the prediction of this model is what I'm being shown on the right side. Now this is the black box network, but now I have the users labeled. It's not just the largest component, that's for that we have the stance information, but all the users, even if they're not connected with the component, they are being labeled. And this magic has to be done in step 3, which is where the model training happens. So that's the goal of this methodological contribution that we have. All right, so just to elaborate a little bit more, we have 3 steps here. In step 1, I extract the text features and user networks out of it. I'll talk in details about what these features and networks will be. In step 2, I will label a few hashtags, usually basically a few hashtags like 2 to 5, 2 to 6 is good enough, but it should be on the both sides. So a few hashtags on the pro side and a few hashtags on the anti side. And the step 3 is where I bring in a model which is kind of motivated by the co-training literature that has been developed for the last 10, 20 years, where we train multiple classifiers together and jointly. And again, I will talk more about how these classifiers are jointly trained and what's the benefit of actually training these in this fashion. All right, so step 1, this is like a very simple step where you have a data set. Let's suppose Twitter data, you collected it just using the streaming API or the search API. And what you get at the end is basically a lot of retweets, a lot of tweets, and some users who are connected based on some of these interactions, like retweets connect some user to each other. What we do is we extract the information out of it. So we have users and text associated with it. So each user will have one or more text. Users will have users hashtags graph, and users will have user retweets graph. Now, one can include more graphs into it. For example, user likes graph, user followers graph. But for this part of this methodology, let's focus on this, but it can be generalized to other graphs as well. And the way we do it is kind of very simple. We just have JSON. I'm just visualizing this JSON this here. So user has some text, which is basically the user's text, and user can have one or more text. Users might use some hashtags. So that goes as a table. So user, hashtag, and weight. And again, user can have one or more hashtags, and he can use the hashtag one or more times. And again, the third network that's being shown here is the user retweets network. So if someone is retweeting him, there's a user and there is a retweet user, and then there is a weight associated with that as well. So that's the extraction of network support. This is the second step. This is where we label a few hashtags. Now, this is the only step where we actually provide a signal to the model of what pro or anti is going to look. So we do have some suggestions on how it should be. And it's basically based on the experience in the last couple of 2-3 years where we experimented with this kind of setting. So we use hashtag that appear at the end of the tweets. And there has been some research that kind of looks into it. And it's the hashtag that often appears at the end. They have more clear signal. And in particular, like stance signal. For example, this tweet has hashtag gun control now, which is again very clear stance signal. So the first thing we do is in that data set, we sort the hashtags by their popularity. And then we label a few popular hashtags that have a clear stance. For example, hashtag gun control now could be a pro gun control stance. And then it's usually like, as I said, it's usually 2 to 4, it could be 2 to 6, like a few on the both sides that we require for this model to work. All right, now coming to the step 3, this is where the model training comes in. For this step, we basically look into a semi-supervised approach, which is more into something called Cotraining setting. What happens in semi-supervised is that you have a lot of unlabeled data, maybe some labels that you might have. And if that is the case, your problem could fit pretty well in semi-supervised setting. And in particular, the semi-supervised setting we are trying to use is we have 2 ideas from semi-supervised. One is the label propagation and one is the code training. And I'll talk in details about all these. Let me first introduce what code training is. So code training is a way to train models. Well, actually more than one model, train one or 2 or more models. That was proposed by Professor Tom Mitchell and Professor Ephraim Blum around 20 years back. And there are some requirements for it. What it requires is that each data point needs to have 1, 2 or more independent views. And by views, I mean that they need to have more than one source of information. I'll talk about what these views are later as well. And what happens in this is that basically it's an iterative process. So iterations goes on, and in each iteration, the 2 classifiers that we have, they try to label some examples, especially some new examples in which they are more confident. So what's being shown here is in this diagram is that in the iteration 1, we have some red dots and some blue dots. These are the labeled examples that we have, and these green dots are unlabeled examples. And then we have 2 classifier views, and each iteration, each classifier is going to add some more labeled examples to the labeled example set. So at the end of every iteration, we have some more labeled examples, and then it iterates over the process. All right, so talk about views, what these views are and what these views could be. So the original example that was given in this paper was basically a web page classification, whether a web page is academic or non-academic. And a web page can have 2 views, which was proposed in this paper. One view is the information in the website itself that's being shown on the left, and another view is the text that links to this website. So, I mean, basically, if you have a web crawler, it can crawl the web and get all the text messages that links to this website. For example, if there is a Professor Mitchell's website, a lot of students will have like my advisor, Professor Tom Mitchell, and I work on something. So that's the text from that page is another view. And basically, the web crawler can give you a number of these smaller snippets, and they all basically summarize, they combine them as one view. So these are the 2 views that we have for this academic versus non-academic classification. And again, the way it works is that classifier 1 will work on the view 1, and the classifier 2 will work on view 2. And again, as I said, each iteration they'll make predictions, and the most confident predictions will be added as new labeled examples in the next iteration. Now you would ask, but we don't have like multiple views often, right? So what are the multiple views in Twitter, or what are multiple views in social media data? But I would argue that actually there are many multiple views possible, and we have already talked about like hashtags can have some information about users' stance. Retweets or followees, these are all actually different independent views. Now, the term independent, though was initially proposed in the Cotraining paper, but it has been relaxed in later work. And it has been shown that even though the views are not entirely independent, the method can work in different scenarios. So in that case, what happens here is that even though the view 1 and view 2, for example, I'm showing here is a user hashtag matrix, and view 2 is just the text. Even they are not completely independent, if in that scenario as well, the method could help. And as I will show in this talk, that it's actually helping us in for stance learning as well. All right, now coming back to the co-training part again. Now we know that there are 2 views, and again I'm showing that in this picture here. In the first on the left, what is being shown here is that we get some seed labeled users using the labeled hashtag that we have, and then the 2 different classifiers. The view 1 is a network-based view, the view 2 is a text-based view, and they again have their own methods of of classifying other nodes, and whichever node are more confident, that's basically being added, what I call as label mixing step. There's a third step. And so every time there is an iteration, we have few more labeled users for their stance in the data set. And then as you iterate, it converges after a while. And then what you have is basically a trained classifier for these two views, but also what you have is labeled users as a result of this process. All right, so just a little bit more details. The algorithm that we proposed is basically label propagation algorithm on network-based view, and a text classification support vector machine model, which is a text-based view. So I will not go into details of this algorithm because of the time limitations, but essentially I have mostly covered what's there in this algorithm. We get seed labeled users from these seed labeled users, from the seed labeled hashtags, and we have a lot of unlabeled users. What we do is that now in iterative process, in the step 1, there is a label propagation. In the step 2, there is a text classification, and in the step 3, there is a mixing that happens. This is where more and more users are getting added to the labeled set, and this iterates. All right, so I'll go into details of each of these classifiers. The classifier 1 is a label propagation model, which is a network classifier based. You might have some more advanced or recent models of which is more of a network based. But for us, the label propagation model is actually very fast, and it works pretty well. So there is no need to say, let's suppose a graph neural network for this kind of problem. But there's still a problem with simple label propagation. A label propagation that's just based on user-to-user network, that basically doesn't scale that well. And the problem here is that we often have networks which are more like a power law distribution, and you might have like 100,000 users and a few thousand hashtags, but only a few hashtags will be more popular. For example, if there is a power law distribution, there will be like 5-10 hashtags which are very, very common, and rest all are basically not common at all. If you want to convert this user hashtag to a user-user network, you'll basically convert 100,000 users across 200 hashtags to a 100,000 cross 100,000 user network, which basically does not scale well, and it also takes more time. So rather than doing a label propagation on user-user networks, we propose a label propagation model which is on a bipartite network, which is a user hashtag network itself. So what's being shown here is that if there is a hashtag stance and there is a user stance, and you know how many hashtags, how often a user uses the hashtag, so you have weights, and that can be used to basically propagate this information on this bipartite network. But there is still some more details that's coming in here. In particular, we don't just use a simple label propagation from hashtags to users, but we also have some influence functions that come in. And this influence function could be as simple as a linear threshold function. And what happens is that it kind of keeps the users more clear. So let's suppose a user who has used 4 pro-topic stance and 4 anti-topic stance. That user is basically more confused, and I mean, it's fine to label it, but we are not very confident about that. And what happens is that, so we label users, but we label in a way that we first label more confident users, and as we iterate over the process, we start taking less confident users as well. So there is a threshold function that kind of helps in doing that. And this is just, it's also like an influence function that we often study. So this is a kind of a label propagation model in its entirety, from users to users on the user hashtag network. So users have used hashtags, so we have the weights information, and we have the influence function sigma, which kind of uses these weights in the stance. And then the hashtags from those, the stance from these hashtags gets propagated to users. And again, this is a similar influence function that keeps in, basically makes the spread of influence or the stance clearer. All right, so that was the first network-based model. We have a second model, which is more of a text-based model. So the text-based model is basically looking at multiple tweets that a person or user makes, and how we can use that to integrate in this co-training setting. So a typical text-based classifier could be like a support vector machine. It's a East EM process. So you have a lot of labeled examples. You basically train a model and get the parameter theta. And then you have a lot of unlabeled examples. You use a text classifier to make predictions. So that is how a typical text classifier works. But for this case, we are trying to use something which is slightly different. It's called text classifier with self-training. And what happens in this self-training is that if you have a lot of unlabeled examples, you can actually improve your text classifier. And the way it works is that every time you make predictions, some of the predictions are being used to retrain the text classifier. This is what is being shown on the right side. In addition, there's also a confidence function that could be used. A confidence function could be like a user has used 5 text messages. 3 of them are pro the topic, and 2 of them are anti. So your confidence is basically 3 upon 5 whether the person is pro topic or not. So basically, we use this kind of confidence information to again have the same thresholding function to basically have, as we expand, initially we want to have cleaner labels, but as we expand more and more, we might be able to lower these thresholds and spread it to the entire user's network. Now, this is the same thing that's being shown in equations. Sj is basically the stance of the users based on the text, and Cjt is basically the confidence that we have. And the way it works is basically if the stance of the users is more than what the confidence is, the function ft is, which is a uniformly decreasing function, then we take the stance of the user. Otherwise, we keep the stance as 0. And this function, since it decreases, so basically more and more users will get some labeled stance as it propagates in the network over the iterations. All right, so just to summarize what's happening here, so we have multiple classifiers that are being trained, and all of these 2 classifiers can make predictions. But in addition, they can also have some confidence estimate in the predictions. Now, we use this confidence estimate to basically fit into the co-training setting, where the more confident examples are being picked as new training examples. We call it a label mixing step, where labels from these 2 classifiers are mixing basically. And as you might have intuitively that if a classifier 1 is good at predicting certain part of your network, and classifier 2 is good at predicting certain part of the classifier. Now, classifier 1 can help the other classifier to get into some parts of the data where it was not possible for it to do earlier. So that's where these label mixing comes in. And we just add some few top confident examples. So we usually pick like top 5%, which kind of works well in this kind of problem environment. The last thing I want to introduce here is like a joint model. Now, given that you have 2 models, a text-based model and a network-based model, and you also have the confidence, it's easy to kind of have a joint model which says that whichever classifier is more confident, I will use the prediction of that classifier. And let's just make it a joint model. So now we have basically taken benefit of both the models, and then that prediction might be better than either of the 2 models that we are training. All right, so just to summarize, these are the steps. Step 1, data extraction. Step 2, labeling some hashtags. Step 3 is basically the co-training of these 2 different types of classifier, text-based classifier and network-based classifier. Now, before we go into the COVID discussions, it's important to understand that how good these models are. The only signal that we're giving is basically some hashtags. So are they actually good enough to actually try in real life or not? So for this, we use the labeled dataset, which was kind of released a few years back. This work was done by Liu, I think, who's at Google these days, and on at Bias Watch. So he had 3 events, kind of controversial topics: gun control, Obamacare, abortion. Some users were labeled as pro, anti, and neutral. Around 500 users were labeled in each of the data sets, where the entire data set was basically around 70,000 to 100,000 users for each of these data sets. So we test our method on this data set. We started with some hashtags that we labeled. For example, for gun control, hashtag gun control now is a pro, hashtag and gun violence is pro. And the other side, hashtag second amendment is an anti, and hashtag second amendment, which is spelled slightly differently, is also an anti. So using that, we get a small set of seed users, around 1,000 to a few thousand. And this is what acts as the initial seed of users that we use. Now, a little bit of more details on the experiments if you're interested. So we use a 3-hop label propagation. So 3 to 5-hop label propagation kind of works well. And we use our SVM text classifier. We also tried like some other classification approaches But SVM is kind of very fast. It uses TF, IDF, and unigrams and bigrams, and it works reasonably well in our data set. And especially some of the data set that we have could have like 100,000 to million examples. It's important to have a classifier which is kind of faster. Hyperparameters that we use were determined on the gun control data set. And in particular, we have basically top 250 hashtags and top 500 retweets were being used for these experiments. So this is how it works. So it basically, in this graph, what is being shown here is on the y-axis, we have the accuracy. On the x-axis, we have iterations. And we talked about, the iterations are basically where you are expanding users in the training set. And the way it works is that in the initial few iterations, the accuracy will improve just because we're getting more and more data. And then it kind of becomes stable, or it can deteriorate. One case when it often deteriorates is the blue line, which is the self-trained gun control model, the text-based one. And this is also very common. Like if you have a self-trained text-based model, it improves, and after that it decreases. What happens is that as you use more and more self-labeled examples, it basically brings more noise, and that's why the accuracy decreases. But with our approach of co-training, where we have more and more confident examples being used, and then it iterates, we don't have that problem. So the joint model, which is the purple line at the top, is kind of basically gets around 0.86 to 0.87 accuracy on this data set, and which is kind of much higher than any of these models, any of the other classifiers that we have. And if you want to visualize how it looks like, on the left side is basically a text-based self-trained model, which was able to get around 68% accurate. And on the right side, the co-trained model, which has multiple retweets and hashtags network and text classifier as the different classification models. And as you can see on the right side, it's much more accurate, but also visually it looks like, it's often able to detect like there's a polarized structure where you have users which are kind of more red, but users which are kind of more green. All right, so these are the same results with on different topics of the data set. So we have for abortion, we have for Obamacare, and the results are kind of almost the same trend. The text classifier improves by around 70% on all three data sets, and we use label propagation, bipartite LP label propagation model for all these data sets. One question that's commonly asked is that, so how much is it dependent on the hashtags that we chose? And I would say it does vary a little bit, especially if you use hashtags which are kind of not common at all. And what happens is that you don't get good seed labels, and then the model doesn't work. But we saw here in this the same kind of comparison. Even if you use just use two hashtags, often we are able to get accuracy which are kind of comparable with all the hashtags, so 0.83 to 0.91. So it's often not as bad as long as the hashtag that's been selected has enough seed labels. All right, so I can take any questions. This is just the methodology so far. Now I'm going to talk a bit about coronavirus discussions and the three controversial topics that we have, and how the users and the pro and anti groups look in those kind of conversations. If there is any question, you can ask me now, or you can wait till the end of this with this talk. All right, so let me cover this talk first. So we just covered how to identify users that are pro or anti given a topic, and we talked about a code training setting where we train multiple classifiers. Now we're going to talk about how the two groups. Let's suppose now you're applying it on COVID discussions, and you want to see how is the group, which group is smaller, what kind of patterns that they have, which group is sharing what kind of data. How do we do that? Now the one thing that I want to just re-highlight about that, once you have a users labeled, it's much easy to basically get other entities labeled, because you will have users hashtags network, you will have users web URLs network, you will have user media URLs network in the data, you will have users likes. So it's much easy to propagate this information from users to hashtags or other entities that you have. In this talk, I'm going to talk about users hashtags, user URLs, and media URLs or pictures, and see how we can use those information in these URLs and understand how the groups are. So let's get back to our first topic. This is the topic on firing Dr. Fauci. Again, it kind of started like a week or 10 days back, April 28th to be precise. And so the way we work is, as you know, we first collect some data. So we generally collect some data on COVID discussion, which is having terms like COVID, coronavirus, and all. But in addition, I augment that data with search terms like firing Fauci, fire Fauci, save Fauci, so that I have slightly more data to work with. So once you have the data collected, this is basically was done using a streaming API of Twitter. And now we labeled some of the seed hashtags. And in this case, the seed hashtag that I used was, as you can see, fire Fauci, fire Dr. Fauci, Fauci the fraud. These are on the one side, and save Fauci, Fauci is a hero, keep Fauci, these are on the other side. So these are basically the inputs to this model. Just to understand like how the data looks like, it was collected very recently. I mean, basically it's all happening last month. So data is primarily in April timeframe, and that's being shown on the left side. On the right side is the vocabulary side, which often kind of indicates like what kind of topics are being discussed. And often if a topic is kind of getting more focused, a lot of users are basically discussing the same thing, the vocabulary side, the normalized vocabulary side decreases. And that's what is being shown here. And on the lower side, I show the table in which we have how many users are basically in part of this discussion. So I have around 20,000 users which are pro firing of Dr. Fauci. We have around 8,000 users which are anti. And we also have tweets, which is kind of comparable. So we have 45,000 tweets which are pro, and 16,000 tweets which are basically against it. I think the first thing we can do is to just look at if these data that we have collected does make sense. And an easy way to understand social media data is does it follow the usual pattern or not. And that's being shown on the left side, whether it follows the normal log distribution. This is like a thick tail distribution, which you often expect in social media data, which kind of tells us that data that we have is kind of sane. It's good enough to work with. And what's being also shown on the right side is like what are some of the common hashtags that we have in this data set. All right, now let's get into the stance part of it now. I did talk about methodology, and I talk about that once you have the users labeled based on the methodology, you can get the hashtags labeled because you can just propagate that information from users to hashtags. And once you do that, you have basically two set of hashtags. One is which is pro group, and one is which is anti group. So that's what being shown here. Like for this data set, anti-fire Dr. Fauci is kind of using more hashtags, and the common hashtags are Fauci, coronavirus, where is Fauci, save Fauci, Dr. Fauci. And on the right side, which is like pro firing of Dr. Fauci, what we have is more of a fire Fauci with some HTTP URL, Fauci fraud, fire Fauci with some boot bugs and all. This also gives some indication that the model that we have got and the labels that we got is kind of working relatively well, because we see the same kind of distribution that you would expect in hashtags. So once we have that, now we can also do the same analysis for mentions network. So we just collect all the mentions that we have in the data set, and again we see that there's some popular persons that we would expect, like the real Donald Trump, and it also follows the same pattern on the log plot. And if you look at like anti and pro side of it, what you see is the anti-firing. So basically users who are against firing of Dr. Fauci are using Frank Fuguzel and some more members. Whereas on the other side, those who are basically pro firing Dr. Fauci, they are kind of more mentioning real Donald Trump and the speaker and POTUS and some more people. The same analysis can also be done with websites. So again, users have hashtags, users have mentions, users also have websites that they share. So if you look at the websites, we have anti-fire and the pro-fire Dr. Fauci. What you see on the pro side, we have paper.li, which is, I just looked at it and it was more like an aggregator site which aggregates news. And then we also have like usual suspects like Fox News and foxn.ws. Whereas on the other side, we have more like YouTube, New York Times, Washington Post. These are what, so it shows basically these users who are profiling, they use this types of data set, they're using these types of news, and on the other side are basically using slightly different kind of news. I also looked at some of the pictures that's being shared, and which are more common pictures, and kind of the division is also not very clear, but also there are a lot of pictures that came in. So if you look at pro-firing Fossey, you have more of a Trump, our rights, our Trump, your fear, and on the left side you have Fossey make science great again. That's kind of more common in this kind of data set. All right, so just to summarize what we see in this Dr. Fossey summary, we have more users in the dataset who favor firing of Dr. Fossey. This was a 20,000 across compared to 8,000. Those who favor commonly firing of Dr. Fossey, they commonly use Donald Trump, as compared to those who are against. They often mention Frank Figliuzzi. I hope I'm pronouncing his name right. Also, there is a comparable difference. There is a visual difference in the way these groups are using different media sites. For example, one group is more on the paper.li and foxnews.com, whereas the other is more on New York Times and Washington Post. Now we move to our next topic, which is the opening of the United States. So we talked about firing Fossey. Let's talk about another controversial topic, Open US. And the steps are basically the same. We have some tags which we use to collect data. And then we have some labeled hashtags that is an input of the model. And the hashtag that I use, reopen America now and the lockdowns. Another side was stay home, stay safe, and stay home. And again, just the general trend of the analysis. Again, the data is basically the last month. So it basically peaked in the last 2 weeks. And then the vocabulary size, as expected, is basically narrows down as there is more and more discussion about just one topic, which is the opening of US. And if you look at the users and the tweets, so we have a lot more users who are pro. So around 600,000 users and around 390,000 which are anti-opening of the US. But surprising to see that the anti-opening US, these users have more tweets. So those few users who don't want US to open right now, although they are less in number, but there are more tweets that are associated with those users. If you look at the hashtags, it follows basically the same pattern that we looked at, power law pattern, but also the stay home, COVID-19, stay safe. These are the common hashtags. Now we can look at like the stance analysis of it. So those who are anti-opening of US and those who are pro-opening of US. And again, it looks like there is a clear distinction between these two groups. And on the left side, we have stay home, stay safe, which are kind of the top popular hashtags. On the other side, we have coronavirus test failure, and immigration ban, and fire Fossey, and reopen America, and Trump. That's being picked up as basically the top hashtags. So we did the same analysis for mentions as well. It again follows a typical power law distribution, which we do expect. And if you look at the mentions in pro and anti, the more anti-opening group, they have, I don't know, it's KS and GTY official, and there are some other foreign nationals, Chiru tweets. On the other side, if you look at pro-open US, we have reader Donald Trump, relentless board, and some more politicians that basically come in at the top mentions, which does make sense, at least on the pro-open US side. We also look at the website. Again, there is still a clear distinction. What you see on the anti-open US side is there is a lot of social media pages like YouTube, Instagram, YouTube. We do have some not so common, like uptrend.com and natalie.mu. And it does appear that these are basically users who are not necessarily from the US, but maybe from the outside. Whereas on the other side, with the pro-open US, we have like azcentral.com and washingtonpost.com, newsweek.com. These are kind of the websites that are being used by these users who are either the two groups. We did look at the pictures, and that also gives us some good glimpse of what's going on. And interestingly, what we see is that for the pro-open US, there's a lot of pictures which doesn't look like US-based. There's a lot of cartoons, some Korean cartoons, and whereas on the other side, anti-open US, we do have like the traditional, what we would expect, the Fossey and Trump and those kind of pictures that are coming up. So just to summarize on this topic, we do see that more users in the data set favor opening US, but they have lesser tweets That's interesting. Those who favor open US commonly mention Donald Trump and relentless board. So these are the commonly used mentions. Those who favor open US also use Easy Central and Washington Post as compared to others who are using more social media like YouTube and Instagram. The same is pattern is also evident while sharing the pictures are basically media items. All right, now I will move to the last topic, which is the ban immigration. So this is also like the smallest topic that we have in this discussion. So we have pro-immigrants. So I did use a few tags again. So in addition to the general COVID data collection, we used like hashtag immigration ban, and then I labeled a few hashtags just to look at, just to basically provide signal to the model. And then the trend that we see here is again similar. The data is mostly like a few weeks back, and the vocabulary size actually dig deep down when that was discussion happening. This discussion is kind of more evenly balanced. So we have around pro users 60,000, whereas anti-users are also around 57,000. So the distribution is slightly different from what we have seen in the earlier two topics. The pattern is still like the social media general trend. So the log plot says that this is the right distribution, and then on the right side, the common hashtags are basically coronavirus, breaking immigration. So if you look at the pro-immigration ban hashtags, these are more like immigration, Fox News, COVID-19, Trump. Whereas if you look at the anti-immigration side, they're more using like coronavirus, abolish, IC, and SCOVY, global, help them help, etc. A similar pattern with mention analysis as well. This is on the left side. These are the common mentions. Real Donald Trump. On the other side, on the right side, what we see is the same thick tail pattern that we expect in social media data. So the common mentions that we have seen in pro-immigration is Abraham Angle and real Donald Trump and some more like Jeff Sessions. Whereas on the anti side, we have some judge. DFW Airport, Jason Whiteley, Bernie Sanders. So there is again difference between what these mentions are being used, how these mentions are being used. If you look at the websites also have a very good difference. So the Fox News, justnews.com, and a few more are kind of more pro-immigration ban, and the Guardian, Washington Post, Independent.co, they're more of anti-immigration ban articles. If you look at pictures, I think there was not a very clear difference, though I could see like on the left side, there is some, on the coronavirus is not an immigration issue, there is some support which is anti-immigration, but there are otherwise more of a Trump-based tweets. And on the pro-immigration side, it's again more like Trump is commonly being used as pictures in those tweets as well. All right, just to summarize what we see here, users are kind of equally active on both sides for this topic. Those who favor immigration ban, they commonly mention Abraham Angle and Donald Trump as compared to those who are against, who mention Jason Whiteley and Bernie Sanders. Those who favor use Fox News and Washington Times as compared to Guardian and Washington Post shared by the other side. All right, so it's kind of covered the second part of the talk where we use the methodology that we developed in the first part and apply it to discussions on COVID. Now we're moving towards the third part where we try to understand users and how they actually differ across these groups. So are all users like in FIRE, Dr. Fauci camp, there are Trump supporters, or how is that playing a role? So to answer that question, the first thing I did was I again did the same, ran the same algorithm and got pro-Trump and anti-Trump labels for all the users that the data set. This is basically a joint data set, it's a union of all the three data sets. So I have more users, I have 37,000 users which are pro-Trump and 430,000 users which are kind of anti-Trump. And then I use some popular hashtags which are pro-Trump, anti-Trump to train the model. So how does it look like? So let's suppose now we have pro-Trump, anti-Trump users that we have predicted, and we also have like pro-open US and anti-open US that we have. Now, it's very clear that there is this very strong correlation. So this is basically a confusion matrix. If you look at pro-Trump, which is, and pro-anti-Trump, which is on the y-axis, and you look at pro-open US and anti-open US on the x-axis, pro-Trump and pro-open US is basically 0.98. So 98% of the users who are pro-Trump, they are likely to be like pro-open US as well. And this is not surprising as well, this kind of way the political discussions evolve. But if you look at FireFossy, the trend is slightly different. So in this case, we again have pro-Trump, anti-Trump on the y-axis, and this is confusion matrix, where we have pro-FireFossy and anti-FireFossy. However, this time the correlation is not as strong. So not all users who are basically pro-Trump are saying that they also want Dr. Fossey to be fired. And again, perhaps this is probably what you would expect from this discussion. So it kind of shows that it's not just a partisanship, but there's also another belief system that gets into play here. And lastly, I have the ban immigration, which is kind of a very different pattern from what you have seen in the last two. So in fact, there is no good correlation between pro-Trump and pro-ban immigration. And same use case is anti-Trump and anti-ban immigration. We can't confidently say like how many users are pro-Trump as well as pro-ban immigration. And probably this also reflects the ground reality, where just having pro-Trump doesn't really mean that a person would also be pro-immigration ban or against it. So this is what I basically looked at. So I just summarize. I basically looked at 3 questions. We started with the methodology of how we can do this kind of analysis of stance. We looked at how these groups are and how they actually differ in sharing different news sources, mentioning users, whether they're smaller or larger. And lastly, we looked at like how these users differ across these topics. So are all users who are in fired Dr. Fossey camp are Trump supporters? And answer was no, it's not like that. So I think that is all I have. I would just like to thank you all for listening to this talk. And we also like to thank our sponsors for supporting this kind of research. I think that's all from my side. I'm happy to take any questions.
Sumeet, can you speak for a moment about whether or not you think this approach could be used to support policymakers or journalists or government officials? I mean, do you see any uses of this approach in that context, in those contexts?
Yeah, that's a good question, Professor. Now, most of the analysis that I do here is basically based on Twitter, and there's a research which says that up to some extent, what happens on Twitter could be a reflection of what happens on the ground, but that necessarily is not true. So I think in that way, making a policy decision could be tough, though getting some intuition from this kind of research could be actually helpful. For example, one thing that I looked at when I was looking at like Open America, and I looked at like those who are pro Open America, it appears that there is a lot of users who are not US based, and that could be something that could be looked at. And it's like, is the discussion that's happening is kind of driven by mostly local users are not by local users. But as far as I understand, making a strong policy decision just based on Twitter analysis, I think could be challenging. But there are insights that we can definitely get from it, and then we can have more ground verification of those insights.
That answered my question. Yep. And for everyone else, just raise your hands and you'll be unmuted so you can ask questions. So while we're waiting for that, maybe you could speak for a little bit about, you've got these different cases. Yep. The Fauci one is very strong. Are you seeing similar people as being are you seeing similar kinds of things among those who are anti-Fauci and those who are pro-reopen?
So I expected that in the beginning, that those who are pro-firing Fossey, they are all Trump supporters, and those who are pro-Open America are also Trump supporters. But as we see in some of the analysis of the dataset, that's not all true. Especially, yeah. So there is a variation that is basically happening. So just if you look at like some of the confusion matrices here, so the Trump is kind of very strongly correlated with Open America. So there is a very strong partisanship here, whereas pro-FOSSI, the partisanship is kind of much smaller. And also, it does based on some of these websites that's being used. Open America, especially, is using a lot of social media, where that's not the case with with FireFossy. Like we see a lot of YouTube videos where there, and also the pictures. Open America had a lot of pictures which appears to be more like cartoons, which was not again the case with Dr. Fossey. So I think the short answer is that initially I expected that, but I think the outcome, what the data shows, is basically that's not entirely true.
And so what do you think accounts for that difference?
So I think sometimes you mentioned that there, for Open America, there might be some kind of foreign influence that's kind of changing the discussion that's happening here. So that's definitely worth looking at, and it does make sense. Like, you know, there might be some actors who are interested in opening America sooner, maybe because of some vested interest, but they don't really have much of interest in Dr. Fossey getting fired or staying in his position. So that's definitely one thing to look at.
Hello, thank you, Sumeet, for the presentation. I have a question about, did you consider those who will use a hashtag that is against their stance? So for example, those who are anti-Trump but would use a hashtag that is pro-Trump to just reach to another audience.
Yeah.
So how would you take these people into consideration while building your model and then applying it and interpreting the results?
Yeah, that's a good question. And I think there are two ways we basically attack that problem. And as you expect, you know, this is kind of a very common thing that people often do. People often use hashtags to basically use it more like a topic to target some users on the other side. And the two ways we look at is basically the first level of filtration happens when we only use like the end hashtags, which we can call like end tags. And that's like, if there is a hashtag which appears at the end and it says hashtag gun control now, that has a more clear information. But then more importantly, the model that we have, the Cotraining model, it also has those influence functions, which kind of thresholds any users who are kind of using mix of hashtags. And also the Cotraining has those, the label mixing, which also kind of uses only the more confident labels in the step of training. So basically, a lot of users who might use hashtags from the other side, but we don't expect that they will be only using hashtags from the other side. We expect them to use hashtag which is from the one side as well as from the other side. And the model kind of captures that and has ways to basically handle that kind of usage.
Thanks.
Yeah, sure. And basically we verify it using, you know, some of the data sets, the 3 data sets that we have that I talked here, but we also have other data sets that we looked at. And we basically verify that this method kind of is, I wouldn't say proof against, like this is completely foolproof, but it kind of handles this problem relatively well.
We don't see any more questions. We hit our bewitching hour anyway, so thank you very much, Sumeet. And so big round of applause, and we'll see you all next week.
Thank you, guys. Thank you, Professor.